Okay, so the next session is lazy evaluation. In case of lazy evaluation, if you know in streams, and it's lazily evaluated in meaning that you just build a plan with the intermediate operation. So you say filter, okay, I want a greater than 2. And when you say map, okay, then I only want the customer ID, or I only want unique, or I want to be sorting it, or I want to limit it, skip peak. You're just building the pipeline. You're not executing it yet. When does your execute happen? So you in lazy evaluation versus eager evaluation, you save a lot of time. In terminal operations, you're going to collect, you're going to reduce, you're going to for each, count, find first, any match, all match, min array, max array, to pipeline. And in these cases, your entire pipeline, that's when your actual execution of the plan, it happens. So there is a performance benefit to it because it cuts down the number of steps when it executes it. So let's not waste time. Let's get started on the examples. In this case, what's happening here? You define an array as list. You have a bunch of integers. And then what do you do here? You have a number stream. You're doing a filter. You're just doing, this is your condition, n divided by 2 equals 0. That's the first step. Map. In map, what you're saying, you want to change the number to n by 10. So filter is a predicate, it's associated to condition. Map, what is it? A map basically does some computation on it and returns you a new list after that computation. But in this case, what's happening? The pipeline's built, but there's no filtering happened yet. Now you go and call collectors.list. And when you call collectors.list, this operation gets triggered and this operation gets triggered, and hence you get the results. And also all the numbers, one will get skipped at the first, only two will go into the second map. So you skip a lot of operations also when you add these blocks. So when you add filter blocks, you have to add them logically because you want to halt, you want to reduce your data set, right? In this case, you're not going to go to this step unless this step is clear. So then you compress your data step. So that's another advantage other than lazy evaluation, also to reduce the number of steps, reduce the number of iterations to achieve your end result. So the shorter your list, the faster your execution time. So now let's go look at the in this case, it's not reduce, come on. Lazy evaluation. Okay. In case of lazy evaluation, what it's doing, there's no filtering or mapping happened. But when you call collect, what happened? It filtered. It went to 1, then 2. Since it has to be divided by 2 is 0, so it went to 2. Then only it went to the map step. Then the next time 3 is not divisible, 0, it skipped it. Then it went to 4. So you're saving a map operation at 3. You're saving a map operation at 1. Right? Saving it at 5. So you're cutting down on the number of steps. And anyway, your result, collect to list, your end map result is 20, 40, 60, 80, and 100. So that's the advantage of lazy evaluation. In short circuiting, you suppose, you have this list. You have how many elements in this list? 1, 2, 3, 4, 5, 6. You have 7 elements in this list. And now you only want to filter by greater than 100. And then you want to find the first element that's greater than 100. So then you filter greater than 100. So it goes to the first element, second element, third element. At the fourth place, it found 150. And you got to find first. So now it gets out of the loop. So it doesn't bother to check 200, 300, 400. So there again, you save on the iterative cycles. So short circuiting, see, checking for 10, 20, 30, 150, found 150. It stopped. It didn't process 200, 300, 400. So that's the benefit of this list. First large, or else if it doesn't find anything large, then it's 0. Now it goes through the whole, it will only go through the execution of to 400 if everything is below 100 here. So you save on iterations and you save on time. If you want to exit your loop quicker, then you got to use find first. Or you can use another one. You can use short circuiting with any match. Now, again in this, you just want to print this out, testing n. This is an intermediate loop. This is not going to get executed until you call any match, which is the terminal operation. In case of terminal operation, what does it take? It takes a predicate. It takes a predicate, and what does it say? It says n colon n percentage 7 is equal to 0. Means any number divisible by 7 is equal to 0. So that's going to be 7, right? So it's going to do 2, 4, 6, and then it's going to go to 7, and then any match. And at this point, it's going to get out of the loop. So let's look at this use case. With any match, it goes to 2, it goes to 4, it goes to 6. At 7, your result is true. And so it didn't bother to check this. So it just dismisses the other elements. If you want to reduce the number of iterations, you use this. It stopped at 7. So all this whole set got ignored. It only looked until here. It's looking in sequential order. Infinite streams only possible with lazy evaluation. So now what happens? This is very interesting. You're going to infinite stream that iterate in n plus 1. There is no limit on it. And you want to print the number generated 1 cross 1, 2 cross 2, 3 cross 3, 4 cross 4. But here's what, again, how are you restricting it here? You're limiting it. You're limiting it saying max is 5. And this is again an intermediate operation. And collect is your final operation. So it's not going to go beyond 5. At this point, like just like find first, you could terminate the operation. Any match, you can terminate the operation. In this case, limit, max 5. You can terminate the operation at 5. And then you get the 5 elements in a list. So when you use limit, you prevented infinite execution. So now you go in here and short circuiting using, see, creating infinite streams of natural numbers. You go to 5. And then since you have limit 5, you can't have infinite operation anymore. Next, you want to do multiple operations on an event. Now, this is just a breakdown to show you how the operations, when you have multiple steps, every operation, every event, it goes through its own set of iterations. In this case, what do we want to do here basically? We are trying here at the first step, we're trying to check greater than 8. So that's going to be 10, 15, 20, 25. These will pass the first condition. Now, in case of map, you want to just return to this is going to be 20, 30, 40, and 50. And then you want less than 50. So it's going to be 20, 30, 40. So you have another filter here. Collectors to list, and then you collect it. So this goes through the set of. So here's what it says. Let's go and look at the here. Operation fusion, what happens? It's filter greater than 8, 5, no. Then it goes to the next one. Is greater than 8, 10 greater than 8? Yes. If it's greater than 8, what do? We multiply by 20. Now is 20 less than 50? No, we skip it. Next we skip it. Next we go to filter 1. It's 15, 30. Is 30 less than 50? No. Then we go to 20. Is 40 less than 50? Sorry, yes. And filter to less. So then we get, it has to be less than 50. So we get 20, 30, 40. For some reason I was thinking it has to be greater than 50, but the final condition was lesser than 50. So we get 20, 30, 40. Now let's go to, it reduces the iterations, it reduces your subset. It doesn't execute it until you hit the terminal operation. So those are the 3 benefits of streams. When you use an eager approach like this one, if you use an eager approach, like, you want to filter all n, and then you do this, and then you do a collect. It processes all the elements at each step. Next you go and you do a map all. Mapping all the filtered elements. Then you get the filtered stream, right? And then you go and map all the elements. When you use a lazy approach, lazy and even in intermediate, you got to, if you want to reduce the number of steps, you have to put them all together in the same function. If you separate them out, then they get collected at every juncture. So that increases the number of steps. When you give it like this, right? Then it's going to go and apply it on everything. But when you bind the operations together, then they go through less iterations. This is like a single pass versus fused operations. If you do the fused operations, you go down on your number of steps. So this is faster. Now, if you go and look at example 6, right? In eager, you see it's going to filter all and then mapping all. When you do a lazy approach, it filters on each element in one pass. So you reduce the number of operations here. And then you go into next terminal. What is 7 is what? Terminal operations. Yeah, this one is nothing happens if you don't enter any one of those terminal operations. Like if you don't enter this terminal operations, collect or reduce or for each or count, find first, any match, all match, min, max to array. Your pipeline executes only when you run terminal operations. These operations are just like a plan for execution. They do not trigger anything. Now, the performance benefit is assume you have a huge stream. Take 1 million records. You want to find the first element 500 in a list of 1 million. When you do find first, after 500 elements, you're out of the, um, you've cut down on your time. You're not looking through 10 million elements. So that is the advantage of streams. Sorry. Let me go to the end. Here's the performance element. Finding first element greater than 100. It found 501 and the time was 0.89 milliseconds. It only checked 500 elements. So that's the one of the benefits of using streams. Intermediate operations build pipeline only. Eager is terminal, execute entire pipeline. All operations applied per element. Short circuit is stop early. You have any match and you have find first. Efficient is no wasted work on unused elements.